I'm going to do a tiny bit of review here at the top. These are exponential, so I'm just going to convert this to a log real quick. You're going to see this in many of the questions today, so I want to make sure we know how to do it. These are all true, bless you, true statements. So 8 squared is 64, okay? To write this, let me grab a highlighter here actually. To write this as a log, so this is exponential form. Most of the time we're getting it out of, or we're getting it out of log form and putting it in exponential form. I'm gonna put this in log form. So this is gonna swing right across this equal sign. When you do that, the 2, the exponent, comes down on the level with the rest of the question. Whatever that base of the exponent becomes the base or the little subscript for the log, so it'd be log base 8 of 64. So the base of the exponent becomes the base or the subscript of the log when you convert that to log form. That's all we're doing. We're not solving anything. These are both true statements. I'm just trying to remind you how to do this because you're going to do it in some of the questions today where maybe one of those numbers will be a variable. Okay, kind of same thing here. So the base of the exponent, I'm going to swing that across the equal sign. When I swing that, it brings the exponent of -3 down on the level with the rest of the question. Then I'm introducing a log because I'm trying to write it in log form. The 2 becomes the base or the little subscript for the log, and then 1/8 is just going to I'm just going to kind of scooch it over, but it kind of stays where it's at. So that's converting the base of the exponent, now the base of my log in log form. Okay, does anybody have a question? Okay, I am going to write you the formal definition of this, and then I will write it with some numbers so we can make a little bit more sense with it. But this is called the change of base formula. This is true. You can change the base of the log of to anything you want. Usually what we do is we'll change it to base 10 because then we can do it on the calculator. All right, so I'm going to write the log base b of m. All right. Now, here's how the change of base works. You're going to do this is made fraction, the log base c of m over the log base c of b. And then, like I just mentioned a second ago, typically you try to change it to base 10 because then you can do it in the calculator. So here's how this would work. I'm just going to make something up. Let's say we had, here, let me use the one we have right above and I'll show you that it'll work on the calculator. Most of the time it's not nice numbers, but let's say we had this question right up here. Let's say I had the log base 8 of 64. Now we know the answer to that is 2, right? Okay, here's how I could do this on my calculator. I would do the log, whatever you're taking the log of 64 divided by, and this is not 64 divided by 8, this is 2 separate logs. This is the log of 64 divided by the log of 8. Okay, now I purposely didn't write it in, but I'm going to go back with a different color. If you just have the word log, it's assumed to be base 10. I'm going to write that just in here to show you guys real quick. But usually change it to base 10 so you can use your calculator to have you do the problem. So theoretically, and you guys should have a log button on your calculator if you're looking at it. If I do log 64, now most calculators are going to pop up a parenthesis when you do that, so make sure you close the parenthesis. So I'm just doing log of 64, and I'm going to divide that by the log of 8. You can close the parenthesis on the bottom, but you really don't have to. It's totally up to you. But this should be 2 if I'm telling you the truth, and then you can see that it is. So I'm changing it to base 10 so I can do this on the calculator. It's going to speed the process up for a lot of these questions. So it's whenever you change this, whatever you were originally taking the log of, so the 64, that goes on the top, and then the log of the subscript, which was 8 for that example, goes on the bottom. Okay, so here's all you're going to do. We're going to change the base. Now, that was a nice answer, right? That was 2. Most of these are not like that. So I'm going to write this to the side. You don't have to write this on your paper, but I'm going to write this to the side. What this means, this in exponential form, would be 12 equals 6 to the x power. That would be the exponential form. So when I do this, my answer would be like 6 to this power equals 12. All right, it's not a nice number because 6 to a power does not become 12. So this will be a decimal. To do the change of base, we're just going to change this to base 10 so we can type this in the calculator. you just do log whatever you were taking the log of, which was 12 on the top, and then do log whatever the subscript is, that's going to go on the bottom, so log of 6, and you just, like I said, you have to be careful on your calculator, you're just going to type in some parentheses. So just log 12, whoops, not 2, 12, close the parenthesis, divide by log 6, and it's, most of these questions are going to give you some big, long, nasty decimal, and that's why it'll say, it says round to the nearest thousandth. How many decimal places is that? 3. Do you know how to tell that? Like 100th, there's 2 zeros in 100, so it's 2 decimal places. There's 3 zeros in 1,000, so it's 3 decimal places. So this would be 1.3, let's see, 87, right? This would be my answer. Now, just to show you, and it's going to be a little bit off because I rounded it, right? I didn't do the whole number. But if I do 6 to this power, this 1.387, just to check my answer there, it should be super close to 12. It's a little bit off because I rounded it, but that's what you're doing there when you answer that question. All right, so again, you don't have to write this, but this one, what this one means, 400 is 5 to this power. That's what this one means. That's the exponential form. If I want to do this, I can't do it because it's base 5, but if I change my base, I'll just use base 10, do log of 400 divided by log of 5. Whatever you're taking the log of goes on the top. Whatever the log of the subscript is goes on the bottom. Just close the parentheses. And like I told you, most of the time these are going to be not nice numbers, and that's totally fine. So I'm getting 3.723. The more decimal places you have, the more accurate it will be. So if you do want to check your answer, the further out you go. So this should be 5 to the 3.723 power. And it's a little bit off because, like I told you, I was rounding it. Is anybody having a question? Okay. Now, can I do this one? You can't. If you tried to type it in your calculator, it would give you an error message. In exponential form, this would be -20 equals 3 to the x. You can't take the log of a negative number, so on this one, you can't do anything here. Can't take the log. If you tried to, like if you did the log of -20 divided by the log of 3, it would give you an error message, but there's no exponent I could plug in to get a negative number. Remember, negative exponents just give you fractions. Cannot take the log of a negative number, so if that comes up, you won't be able to do it. All right, now, here are some exponential equations, and we did one from the homework last night where we wrote the same base, right? On these, there's no way I'm writing 16 as 5 to a power. Or like if I look down here, you're not writing 6 and 21 as both base 6 or something like that. 3 and 101, you're not doing that, like some of the questions we've done before. So the alternative, here's what we're going to do. I'm just going to convert this to a log real quick like we did in the questions at the top. I'm just going to swing this guy over here. When I do that, that brings my exponent out of being an exponent. It just brings it down on the level with the rest of the question. On this side, base of the exponent, which is the 5, becomes the base or the little subscript for the log. Log base 5 is 16. This is not a nice number. Because it's base 5, we can't just do it on the calculator, but we can change the base and change it to base 10 real quick to get this. Just do log 16 divide by log 5. And that should be my answer to that question. And again, just when you type it in, just make sure, for the first one especially, type the parenthesis in there. And I'll show you, if you don't type the parenthesis on the second one, it doesn't matter. It'll give you the same answer. But on the first one, just to separate it from the division sign, make sure you do that. So I'm going to write 1.723 for this. Okay, now, some of the rest of these are a little trickier. So this exponent's got 2x, but I'm going to do the same process. We're going to swoosh the 6 to the other side. Brings the 2x just down on the level with the rest of the equation. So it's no longer an exponent. I'm getting rid of the exponent by converting this to a log. Now, the 6 becomes the base of my log. And so I'm going to do my change of base here to do this on my calculator. So just whatever you're taking the log of, do common log of that. So I'm doing log base 10 to change the base to 10, so my calculator will do this for me. Divided by separate log of the subscript. All right, so log 21 divide by log 6. All right, is that my answer? No, what do I still have to do? Divide by 2. Okay, now here's what I would tell you. Just leave this right on the screen, like right on your calculator screen. I'm going to divide by 2 to get rid of that. So I'm just leaving it on the screen. Just actually type divide by 2 right after you hit enter for that first part, and that will give you the answer. So just keep it right on the screen on your calculator. Don't try to round multiple times. Just do it at the very end. So this to the, let's see. To 3 decimal places, this would actually be 0.85 here, because the 5 would round up the 9, and so we're going to actually just go to the nearest hundredth on that one. Okay, now one more. This one's a little different. So that exponent was 2x. This exponent is x plus 4. And I should have said this. Any of these, if you want to go back in to check, like if I do 6 to the, I'm going to just hit second answer, that power times 2, it should be 21. So you can check these really quickly if you want to plug them back into the original problem. All right, here, I'm going to switch this over here. Now, this whole expression, x plus 4, going to come down on the level. It's no longer an exponent when I convert this to a log. Log base 3 of 101. Now, you don't have to write out every single step that I'm writing here. I'm just trying to show you where this comes from. So I'm going to change the base of that log base 3 of 101. I'm going to do log of 101 divided by log of 3, 2 separate logs there. Not taking the log of a negative number or anything, so I'm not doing anything wrong. Okay, now, what would I do there to get my actual answer? Subtract 4. So just do it right on the screen. So I'm going to subtract 4 from this. So just do minus 4 right on the screen. It is okay for your answer to be a negative number. You just can't take the log of a negative number. This is just a super small number. This is 0.201 to 3 decimal places. Is anybody having a question? Okay. Now, I just have 2 more here that are a little more complicated, and then I'm going to set up some word problems that are similar to what we did at the beginning of the unit. What you want to do for any question that's a little bit more complicated, like what you're seeing here, you want to isolate whatever you are taking to your exponent. So only in that problem, the 5 to the 2x, I want to get that by itself. So does anybody know what I should do first? If I want to try to get that 5 to the 2x by itself, what would you do first? Add 9. Get rid of any addition or subtraction first. So actually I want to add 9 here. Now, I'm not gonna multiply that 3 and 5 together because I would have to do that exponent first in my order of operations, and so we're not going to do like 15 to that power. So we're going to get rid of the 3 in a second, but I'm going to add 9, so I get 3 times 5 to the 2x equals 120. Don't multiply, you want to divide. Just divide both sides by 3. So I've got this 5 to the 2x. Whatever you're taking to your exponent, you want that by itself. Then we're going to convert it to a log here in a second. This will be 40. Now, I'm just going to swoosh this over to the other side, get that exponent down on the level with the rest of the question. We'd have 2x equals log base 5 of 40. All right, I'm just going to do this on my calculator screen right now so you guys can see it. So I'm going to do change of base. I'm going to do log 40, close the parenthesis, divide by log 5. It equals, and then I'm going to divide that by 2 because my exponent was 2x. Just do it all right on the screen. And to 3 decimal places, I'm going to do 1.146. You do not have to write out a bunch of work for this. So just initially, I'm trying to show you where this comes from. And now I have one more. This exponent is probably the most complicated of all the questions today. So I've already got my exponent and base isolated, so just going to get rid of that exponent by changing this to a log. So I'm just bringing that exponent down on the level with the rest of the question, 3x minus 4. This would be the log base 2 of 40. Okay, now I'm going to do log 40, divide by log 2, changing it to base 10 so I can do it on my calculator. That would be the right side of the equation. Once you have that, what would you do to get x by itself? What do you think? Yes, do any addition or subtraction first. So add 4 first, and then I'm just going to do this all right on the calculator screen. Just make sure you get rid of any addition or subtraction first, then any multiplication or division. So we're reversing order of operations. So I'm just going to do this on the calculator screen. I'm going to hit add 4 equals, and I'm going to divide by 3 equals. That's going to be my answer. Just keep it right on the calculator screen because you don't want to round multiple times as you go through the problem because that's going to make it inaccurate. I'm just rounding to 3 decimal places at the end. Does anybody have a question? Okay. Now, these last 3 are a little tricky because we're going to have to set them up, but it's not bad. This is going to be a little review from the very beginning of the unit. This says lunch at your favorite food truck currently costs $6.50. I'm going to write down y equals ab to the x just to remind you. These are just going to be general exponential. So the current cost of this lunch is going to be my initial amount, which is a $6.50. You don't need the 0. I'm just writing it in there. It says the price of lunch has steadily increased. So if we're going up, we are having exponential growth, 4% per year. All right, now, if you guys remember, it depends whether it's increasing or decreasing. In this case, it's increasing. So the b value is 1 plus the rate. So the 1 accounts for what you're already paying for lunch. And when I add the rate to that, that's going to add that extra percentage on for me. So I'm going to go back over here. A lot of times these are given to you as a percent. So you got to change it to a decimal to get the rate. If you guys forget, you take the percent and divide that by 100. It should scooch a decimal place. It's right after the 4. It should scooch it 2 places to the left. As a rate, this would be 0.04. Or if you want, just grab your calculator. Just literally do 4 divided by 100, and it'll tell you the decimal right then and there. You don't need the 0 in front. Whatever's easier for you. But to get my b value then, I have to actually do 1 plus that 0.04. And so 1.04, that's what I'm going to use as my b value. Okay, it says, in how many years from now will the cost be $10? The $10 is going to be the y value. And we're going to solve for how many years. That's going to be the time. So in all the questions we did earlier in the unit, I was like, okay, what is this worth in 10 years? Or what is this worth in 15 years? So this is working backwards, and you're going to actually determine the time, which is going to cause you to have to solve an exponential here. So we're going to set this up. I'm going to write 10 equals 650, or if you want to just write 6.5, that doesn't matter. You don't need the 0. And my b value, 1.04 to the x. Okay, now, these are super tricky, and the thing that everyone always wants to do is take the 6.5 and multiply it by the 1.04. Do not do that. All right, here's what you're going to do. You are going to get whatever's being taken to the exponent, which is only that 1.04 by itself. So I'm going to take and I'm going to divide both sides by 650. Again, I keep writing it, but you don't need the 0. So I'm going to do 10 divided by 6.5. Okay, and I got a nasty number, right? I'm not going to round multiple times when I do this. So I'm going to actually, let me just leave it that way for a second. I'm just going to leave it in that format. So I'm going to write 10 divided by 6.5. It's not a, if it's a nice number, fine. If it's not like that question, don't do it. Just leave it for a second. All you're going to do, I know this is looking a little weirder, but we're going to change this to a log. So I'm going to swoosh this to the other side. That brings that exponent down on the level with the rest of the question. So this would be the log. The base would be your b value, that 1.04. And then what you're taking the log of is that 10 divided by 6.5. Okay, and I'm just going to do change of base, but I don't want to round it multiple times because that makes it inaccurate. Now, when you do this, if you all have a scientific calculator, totally fine. I'm going to do the change of base. Don't use the fraction key, just use parenthesis keys here, because if you use the fraction key, it's not going to like the 6.5. It won't do it if it's a decimal. So I'm going to do log of what I'm taking the log of, divided by the log of the subscript, which is the b value. And if I type it in like this, I'm not rounding multiple times. All right, so I'm getting 10.984. X is going to be the time. So, like, about how many years is this going to take? 11 years. Like I would say this is going to be 11 years. So this is going to happen. Does anybody have a question? Okay, I'm going to do one with decay. All right, so it says you bought a car for $15K. That's your A value. The car depreciates, so it loses its value 6.5% per year. So the rate, divide that by 100, is 0.065. The B value here. So when you have decay, it's like how much value does it hold? So it's 1 minus the rate. So it's losing 6.5% per year. So 1 minus 0.065. So the car holds about 94% of its value, 93.5. But my B value here is going to be 0.935. Now, it says when, or in how many years, so we're going to figure out time again here. When's the car going to be worth $10,500? So this is your Y value at the end. Like, how long is it going to take for the car to get down to that value? So we're just going to plug all this stuff in. So I'm going to do that 10,500, 15,000 here, 0.935 to the X. Okay, again, the first thing, don't multiply that 15K by the 0.935. You're going to divide both sides by 15,000 here. So I'm just going to see what that is, just see if it's a decent number. Okay, that's I'm not on the screen, fired. Okay, that's a decent number, right? I can write I'm not rounding anything here, I'm just writing 0.7. So this is fine, leave this alone. That last question, I don't want to round multiple times, so if it's not a nice decimal, then just leave it as a fraction. Then all you got to do, we're going to swoosh this to the other side. You got, this would be the log. The base of the exponent would be the subscript of the log. So the base of the log, 0.7. What I'm going to type in my calculator, do change of base, do log of 0.7 divided by the log of the subscript, the 0.935, and that'll give you the time. Two separate logs here. So this is like 5.317. So this is like a little bit more than 5 years. This one wasn't as nice as the last one. That one I would have rounded to 11 years. This one I'm just going to leave it alone. It's going to take a little bit more than 5 years for this to happen. Okay, let's do one more real quick. Now, half-life had just a slightly different formula, so I'm going to write this because this exponent's a little more complicated to remind you guys. So half-life, you have your initial amount of your substance. It's like y equals ab to the x, but it's a little different. The b value, we won't have to determine that here because it's going to be a half-life problem, so it's always a half. It's how much, or how long does it take half of the substance to go away? So I'm taking away 50%, so 50% would be left. Okay, half-life is 2.45 hours. So the general form is x over whatever the half-life is, and x and the half-life have to be the same units. It says if you have 100 milligrams of a substance to start, about how long will it take for the substance to have 75 milligrams left? The 75, we want to know when we're going to have about 75 milligrams left, so that would go in for y. We start out with 100. We absolutely know the b value is a half because it's a half-life problem. The exponent is a little complicated here. I don't know the time, so that is x, and it's over the half-life, which is 2.45. Okay, again, do not multiply that 100 and 0.5 together. Like, I don't know why people just can't control themselves. They just have to do it. Don't do it. Divide by 100. Now, this is a nice decimal, right? It's like 3/4, so 0.75. I'm not rounding anything. And let's see, would this be 0.5? Now, my exponent's a little bit more complicated here, but I still want to bring that exponent down on the level with the rest of the question, so I got to convert this to a log. So it'd be the log. The base or the subscript of the log is going to be the b value, which is a half here, and then we'd have the 0.75. Now, when I bring that exponent down, that exponent is a fraction. So this would be, I'd have x over 2.45. So I can do the left side real quick. We're just going to do change of base. So I'm going to do log 0.75 divide by log 0.5. Am I on the screen? I am on the screen. Log 0.75 divide by log 0.5. What should I do with that number based on what I have left over here? What do I do with the 2.45? You multiply. It's exactly. So this is in the denominator. Let me grab a different color. What I'm going to do, I'm going to multiply both sides by that 2.45. If you got it on your calculator screen like I do there, just literally do it right on the screen. So times, oh my gosh, not 24. I did that twice, 2.45. So x is going to be 1.017, and whatever the half-life is, the half-life was in hours. So this is going to take just a little bit more than an hour to get down to 75 milligrams. Is anybody having a question? Okay, sorry, I talked for a really long time today.